This video is about Columnstore. Although this is a SQL technology, I will try to explain it in a very non-technical way by a few simple practical examples. Now we will look into the differences between row store and column store, how the data are stored, how the data are read, and how the data are compressed. We will demonstrate the differences in execution plan for a very simple SQL query and observe the big gains in processing time with a small change in SQL script by using window functions. At the end, we'll look into what can go wrong in implementation of column store technology. What are the key differences between a row and column store? Row store is very much like ERP. It stores transaction in a row store manner. And each SQL page, and that is lowest granularity of SQL space, contains data from more columns, which is good for writing, but not so good for reading it, especially not for analytics. And there is usually little or no compression on this data. Now, column store is a different store where the data are stored column-wise. So same information is spread along the segments and row groups, where each page, 8 kilobyte page, contains data from single column. And this is way better for analytical purposes where we are analyzing the data by columns like date, net sales, store, and that also allows a highly compression usage of algorithms which achieve very high compression. And for execution, each column is fetched independently, so also the queries will process much faster. Creating a column store mode in a table is a very simple step, and this is a statement to create one. So in an index statement, in the index section of a table, we have to write a create cluster column store index. This is an index name on table name. And then we have big differences. Column store will give you 6 times data compression compared to the row store. Column store will process data incrementally 7 times faster than the row store. And queries getting information from column store table will run 8 times faster than same queries running against the row store. All these measurements have been done on behalf of Dynamics Data Warehouse, where the transactional table has 100 million rows, and for incremental we have been inserting 1 million row each time for measuring the exact processing time. In our first example, we will look into the simple query, which is analyzing data across year and document type. The first query is running against the row store, and the second one is running against the column store. So let's execute it first time, second time, third time, so that we have some refresh time, and see it was executing 1.3 seconds. And let's see the column store. We see it's already much faster. And what is the result? 255 milliseconds. So we can say easily that row store is 5 times faster. Now, you may think that this is because of these calculations, and let's just remove these calculations and see how the queries behave if we remove them. Let's fire the query again. It's a little faster, but 970 milliseconds. What about this one? We have to execute it again, like 200, still 5 times. So actually, whether we are analyzing 2 or 5 columns, it's the same. The results are the same. Then the reason why the row store is column store is much faster is actually here in this area. This is an I/O section, gives us information how the memory and disks are using and are working. So we see that the GL transaction table needs 227,000 reads. These are 8 kilobyte pages, which would be approximately 1.7 gigabyte of data to get this query. And in our case, the column store needs only 2,000 reads. So it's like 100 times more efficient. Now, if we remove these columns back, okay, and run this again, and the same here, let's just remove these columns back and run the query again. So what we will see is, interestingly, that the row store, it's reading the same set of data again, 227,000. Now the column store is reading more data because it is required to get the data from 3 more columns. So that's actually a very basic and the most important difference between row store and column store. Row store will always reading the row store will read all the data, while column store will read only those columns and only those rows in the columns which are needed for query execution. In our second example, we will look into how compression works. So this is an Excel table where we copied 10,000 rows from AX retail transaction table, which has 74 columns. Now, in order for column store to execute a query, we do not need 74 columns as we have seen, but we actually need only the columns that are in the query. So if we are analyzing the information about the net sales by store, by date, by company, then we need only 4 columns, the data from the co-columns, and the other 70 columns are not needed. So it's like we would shut down all other columns from a query, and we get 18 times, in our case, we get 18 times less data to analyze, which is clearly a very good and the right approach for analyzing the data. But the data compression doesn't stop here, but actually starts here. And in order to compress data of these 4 selected columns, these data have the original format, nvarchar, datetime, and numeric, which are usually requiring more space than integers. So if we replace this by integers, then we believe that these data will need less space. So how do we do? Now we see that nvarchar, the store name, requires 10 bytes. Now if we replace the store name by integer, and we use this what is called a dictionary, then we can store integers. The same for a company and a date, and you would not imagine that we have 295 different net amount, the values in 10,000 rows. So we can achieve quite a big compression by storing a repeat value and by storing an integer. So by replacing integers, by replacing different original formats by integers, which is taking 4 bytes, we have a gain of 2.4 times in a disk space. Of course, there is an overhead by using dictionary, processing time, and so on. But let's just look into the concepts, right? Now, on the next level, what we do is the following. You may see that the data here for a store is being repeated in every row. So it's 2, 2, 2, 2, 2, 2, 2, 2, 2. So wouldn't it be better if we say, like, everything in the store from row number 1 to row number, let's say 20 or 50, is store number 2. And this is exactly what we will do when we write such a algorithm. So let me explain in my demo case how this works. I have randomized numbers. If these numbers are going to be repeated, then we will have more rows. So if I repeat or randomize a number between 1 and 1, we have 10,000 rows. So there is no interval where the data repeat. But if we repeat the data at least once or twice, then then we need less space. So if the data are, let's say by randomizing example, repeated sometimes between 1 and 10 times, then that's quite common. Let's say in every document, store number is the same, customer the same, date is the same. And actually in this case, we can get, instead of 10,000 rows, we need to write the same information, only 1,786 rows. And our gain in this case is 5.6 times. So row store against the column store is taking more space. Column store is way more efficient because it eliminates columns. It uses a format transformation, and writing in intervals compresses the data and also allows row group elimination. So all in all, you can easily achieve 10x compression of the data when using column store against row store. In our third example, we will see also how execution plan can be different, even the query is absolutely the same and very simple. So let's run this query. The first part is against the row store, and the second query is against the column store. And what we see here that this query was taking 986 milliseconds, and the column store is 5, 6 times, 7 times faster. And we know already because the row store is reading way more data than a column store. But that's not all. If we add also a request for execution plan, okay, so let's see the execution plan. We also see that the row store execution plan is we would say like more complex, longer. It has more nodes, and actually that is true. And I will try just to explain a very simple way. The column store is way smarter because it joins the operation of filtering and aggregating in the same filtering node and sends much less data to the next nodes, which is resulting in much faster query execution. And this is what we call aggregate pushdown, which is possible for those decimals which are up to 8 bytes in size. I'll speak about that later too. There is a limitation of aggregate pushdown functionality as it supports data size up to 8 bytes, 64 bits, which means that integer is supported, or big integer is supported. Big integer has 8 bytes, but decimal with precision 38 is not, because it has 17 bytes. And these are the most used and common aggregations, while distinct is not supported. In our last example, we will show the differences between a simple query where we are looking for a unique value of document number in a row store table, and we are replacing this distinct query by a function, SQL function, window function, row number over partition. And we of course have the same results, but the column store based query with the window function is 10 or more times faster, just because of the enabled windowed function in SQL 2016 are well supported. The query runs way faster. What are most common problems in implementation of column store? First, you have to use SQL Server 2016 SP1 and higher. And the higher the version of SQL, the latest the build that you're using, the better it is. Not just from compatibility level, but also from the perspective of fixing bugs or improving functionality of column store. Column store is a huge functionality everywhere in SQL Server is a track about that, so definitely happened. There were errors in some versions which have been improved in the latest build, so definitely use the highest level, the latest version of SQL Server and the latest build of that server too. Now we have seen for the aggregation, aggregate pushdown functionality, we have limitation of up to 8 bytes of supported decimal or numeric precision, which is sometimes an issue. We have a starting precision with 32 or 38, and some of the columns are not supported. And one quite often used column type, especially in Microsoft Dynamics NAV, is a timestamp, which is used for information when the record has been created, and that this column type is not supported. So you have to create a different column type in your analytics to enable compression. And very often there is not enough memory, so our advice is to put as much as memory as possible into this BI server to enable fast processing of the queries.